Hello, this is Andrew with WMH Racing, and today I'm going to go over some more updates with my battery wizard. This is the fourth video on this product, and I think I am getting close to being finished. I still have a couple of more tweaks in the code, but it is getting really close. I think the next iteration of the board that I get will probably be the last one that I need to get. And like I said, a couple more tweaks in the code. But today we're gonna go over some of the added features. And first thing I'm gonna start with is the internal resistance reading. While I did do a quick internal resistance test in the last video, I've since gone through and tweaked that a little bit better too. So first thing I'm gonna do is check the voltage, and I'm running a little high, and so I've added the kind of a ability to calibrate your voltage. So what I'm calibrating this against is a 5.5 digit digital multimeter that I have, and I'm going to show you. I'm going to go ahead and put that on the screen when I do the IR test. So for this IR test, I do a DC load IR test. So I'm going to put a load on the battery. I'm going to measure the voltage at the start, put the load on, measure the voltage when the load's on, and then you take the voltage drop and divide it by the current to get your internal resistance of the batteries. And that is how I'm doing the internal resistance test. There are some other companies that do internal resistance tests differently. I feel that this is more representative of what we are looking for. Doing the 1S battery, it puts approximately a 17 amp load on the battery, and a 2S battery, it's around 10 amp load. Oh, I got that backwards. Sorry. A 2S battery puts a 17 amp load on it, and a 1S battery puts about a 10 amp load. All right. So just to show you how accurate this is, I'm going to take and I'm going to put the camera over and view my multimeter, and then we're going to look at the serial printout. So I have my unit attached to what is basically a makeshift serial converter to upload the data to my computer screen. So I'm going to shoot the video of the voltmeter, compare it to the output on the computer screen, so we can see how accurate we are. All right. Sorry for the mess. Here is the voltmeter. I'm going to hit the button, and we hit 799,801. Okay. 799,801. So this does 3 readings and averages them, just to let you know. So we got, and the voltmeter is fast, but it's not as fast as my code. So the voltmeter is doing like 10,000 samples a second, where my code's not doing 10,000 samples a second. So my code's gonna read slightly lower. 799, 798, and 797 for an average of 10.06 milliohms and 9.77 milliohms. And we can do this run again and see how close we come up to the same, or how close we get again, right? 9.93, 9.84. So we are definitely getting very consistent results. I mean, within a few, we're going to be, sorry, if we're looking at milliohms already, we're going to be looking at microohms. So we're getting within the 10s to 20s of microohms consistency. Okay. Now I am going to do a 30 amp discharge and show, I don't need this anymore. Okay. I'm going to show some of the new data features, some of the logging that I'm doing now. Let's see, first thing, I got to grab my DRC Lipo safe and put my battery in there. And I'm going to turn on my discharge box fan, so it's going to get a little bit louder. And then navigate through. So we're going to discharge rate. We're going to increase that to 30 amps. I'm going to do 3.6 volts as the cutoff. We're going to run the discharge. And you can see that I've added a couple of things. One, I can't remember at the last video if we differentiated between the lipo cells. So we get the voltage of each lipo cell individually, plus the actual voltage that the battery is at. The cutoff voltage is above that. On the right hand side we have current and the rate that we are attempting to be at with the value, the CUR is the actual rate that we're running. Come down, we get the runtime of the cycle so far, the milliamps taken out of the battery, and then this is the temperature. I have a temp sensor on the heatsink to actually measure the temperature of the heatsink during the run. Now, if we click the data button, we can see that every 15 seconds, starting at the time 0, which is delayed for maybe like half a second to get a value that is under load. So every 15 seconds, you'll see that a value will pop up. So at 75, so we got the voltage at 75 seconds. Oh, what was that last one? So 0, 15, 30, 45, 60, 75. The next one will be at 90 seconds. But I didn't stop there. I actually decided I wanted to add a graph. So the graph populates the same. So at 105 seconds, we should see a new bar pop up. And there is the new bar. So this is showing us voltage versus time. And then the time is in minutes down on the x-axis, and the y-axis has the voltage levels. Alright, it looks like the discharge has stopped at 329 seconds. We pulled out 2,757 milliamps from the battery. Here are our voltage numbers per time. And then here is the graph. Here is the actual curve, a picture representation of the curve. Alright, now I want to do a 1S battery. The question was asked, will this be able to do 1S? Actually, the first thing I want to do is, this battery is nice and warm. And so we're going to go and we're actually going to do another IR reading. To show you that as the battery heats up, the IR of the battery will go down. So you want to, if you're trying to keep track of the internal resistance of your batteries, since it's really difficult to maintain a higher temperature and for testing purposes, you want to test them as close to room temperature as possible. And the reason being is because when we do this IR check, this battery is going to come back, 4.5 to 5 milliohms instead of the 9 to 10 milliohms that it was. So 434 and 455, we'll do it again. And 434 and 451. So again, showing really consistent results. But again, you can't really trust the result from the discharge, because the battery, again, the temperature is going to be extremely high on it. All right, so I'm gonna uncheck or undo that, and I have to switch out my charge lead, since this charge lead is actually not a 1S charge lead. The reason why we need the charge leads, and we can't just do a straight battery connection, is I actually do use the sensor wire to measure the voltage of the battery. So the current draw is going through the big wires, and the voltage sensor is going through the small wire. Alright, and now I have connected a 1S LiPo. This is a really old 1S LiPo. Just to let you guys know, this is a very old 1S LiPo. I remember trying to run it once or twice, and it was a dog. I got it used a long time ago, so I would not say that this is representative of a quality cell that we're testing. It's more, I have this 1S LiPo so I can test with it, and that's pretty much it. So I'm going to put it in the discharge safe. LiPo safe, sorry. And then I am going to, let's see, check the discharge rate. We're at 30 amps. The cutoff, we're going to do 3.5. And I am going to run the discharge. And when I hit the run discharge, it resets all the data values. And it changes the graph. The graph is based on if it's a 1S or a 2S. So we auto detect how many cells there are, and it runs the graph. And again, this is specifically just, to show you guys that it does the 1S test. And 30 amps is about the max discharge that a 1S will handle with this resistor bank. The unit itself can go up to 45 amps. But with this resistor bank, 30 amps is about all you get. You can hook two of these resistor banks up in parallel to get a bigger load to put on the battery, and then you can achieve 45 amps with the 1S. But it will do 30 amps all the way down to a 3.6 volt cutoff, or 3.5 volt cutoff. And there we go. We finished the run with the 1S. It did hold 30 amps all the way down to the 3.5 volt cutoff. 502 seconds. 4195 milliamps. And there's our data. So we got the 8 minutes. How about that? All right. Thanks for watching. Bye.